A new book about global warming that has been influential in Australia has just been published here. It's called The Weather Makers: How Man is Changing the Climate and What It Means for Life on Earth. My guest is the author, Tim Flannery. Australia, like the U.S., did not sign the Kyoto Treaty on global warming. But last fall, Australia's Environmental Minister Ian Campbell said he agrees with Flannery's book and that the debate on climate change is over. The Australian government owes it to the public to tell it like it is. Global warming is a very serious threat to Australia. Tim Flannery is a scientist and conservationist who contributes to the New York Review of Books and the Times Literary Supplement. He's the director of the South Australia Museum in Adelaide and is a professor at the University of Adelaide. Well, you write in the book that you yourself used to dismiss global warming as a major problem. What changed your mind?
Oh, my goodness. Well, I think that what happened to me was that I'd always known about climate change because I was trained as a paleontologist, and I spent 20 years as a field biologist in Papua New Guinea studying that marvellous diversity up in the mountain forests of the island. And I'd seen things there that I now know were related to climate change, but for many years I just had a small insight. I saw a few dots that I knew were related to climate change, but really hadn't spent the time to understand the big picture. And in a sense, I wrote the book to give people the opportunity to develop that big picture understanding for themselves, because that's what we all need to do. We all need to be personally convinced about what climate change really is, how big a threat it is, how fast is it moving, and what can we do about it. So for me, that journey took longer than I really would like to admit to. It was 20 years there where I probably should have been more proactive than I was, and it took me that long to sit down and start reading the science seriously and come to a conclusion, which I did actually fairly swiftly once I'd started to read the science.
Was there a turning point for you?
Yeah, look, there certainly was. In about 2001, the state government of South Australia asked me to chair an advisory committee to advise the Premier of our state about, it's like the Governor, but advise the Premier about issues relating to science and sustainability. And I sat down, started reading those books, and the scientific papers about climate change. It became clear fairly immediately that this was an enormous issue. And then I spoke to colleagues and committee members, gained a broader understanding, and all of a sudden a penny dropped. Those vanishing alpine grasslands I'd seen in New Guinea 20 years earlier all of a sudden took on a new meaning. I could see that they were symptoms of a very serious illness, a very serious global problem, rather than just a local phenomenon.
As a paleontologist, you know the effects that climate change can have on the development or the extinction of species. Is there any parallel that you see between the drastic climate change of the past and the incremental global warming of today?
Probably the best parallel that we have available to us is an event that occurred 55 million years ago, when a vast amount of North Sea gas was ignited by hot lava and shot to the surface of the Atlantic Ocean and put an enormous pulse of greenhouse gas into the environment. And that changed our planet completely. I mean, all of a sudden there was rainforest growing in Greenland, where previously there'd been cooler forests. And the oceans acidified. You can look at the ocean sediments dating to that time around the world and see that they've just been eaten away quite literally by acid. There's evidence of massive extinctions. Now, that was a very large scale and very rapid change. What we're seeing today is a similar increase in greenhouse gases in the atmosphere, but not to the same volume as yet. In terms of speed, probably a little bit slower today, but nevertheless, the changes that we're seeing now in our modern world are on a scale which it's very fast and very large compared with previous climate change, particularly those over the last few million years.
It is fast because it seems more rapid than in the past, but still kind of slow. What do you mean by fast?
Well, if you look at the changes that occurred at the end of the last ice age, which are probably the best documented of all of the prehistoric changes, 15,000 years ago, New York, Boston were covered by ice, and the shift that occurred in the climate that brought about the modern climate we enjoy today happened over about 7,000 years. And over that period, the Earth warmed by about 5 degrees Celsius, which I guess is around about, 11 or so degrees Fahrenheit. So comparing that with the changes that are projected to occur over this century, scientists are projecting an increase in temperature over this century of about 3 to 3.5 degrees on average. So you can see it's not quite as big as that earlier change, but it's happening about 30 times faster. And when it comes to climate shift, of course, the rate of change is every bit as important as the extent of change, because species and people and cities and everything else need time to adjust to new conditions.
Now, you point out in your book that warming is a slow and incremental process, but global warming can change climate in jerks, during which the climate patterns jump from one stable state to another. Can you explain this?
Yeah, look, this is one of the most fascinating things that we've learnt about climate science, I'd say, over the last couple of decades. You know, that what we see is that the increase in greenhouse gases in the atmosphere is gradual, and the warming, therefore, is gradual, but that the whole climate system, which really means the way that the world's climate organises itself, or the atmosphere organises itself, shifts very dramatically in just a single year. And probably the best documented example of that occurring was 1976, when the entire world's climate changed in just a single year. People in the States may remember that year, the quite extraordinary winter snowfalls that occurred in some areas, and the very mild conditions that occurred further north. Well, around the world, changes that occurred in 76 have remained permanent. So there was a jump in the way the world's climate system organised itself. And the same thing happened in 98. And the reasons that the climate system responds in this way are not very well understood scientifically, but what we're beginning to understand is that the atmosphere itself is telekinetic. Now, telekinesis means movement or action at a distance without a visible means of connection, and the climate system seems to organise itself telekinetically through pressure waves in the atmosphere. And once they change, it's very hard for them to change back. And the climate system seems to work in exactly the same way.
Now, do you think that 2005 represented one of those shifts in climate? You know, we had incredible. We had more hurricanes, certainly in the United States, and more severe hurricanes. And I think 2005 was it the warmest year on record?
Yeah, it was either the warmest or the second warmest. I think there's a tiny bit of debate about that, but nevertheless, we're on an upwards trend. And I don't think 2005 was necessarily what they call a magic gate year, when the system shifts from one state to another. But what we saw with hurricane activity in the US was certainly exceptional, and very consistent, in fact, with what we see globally in terms of these extreme weather events. You know, one of the really big surprises that the world is teaching us is that the computer models that we use to try to understand how the climate system will change in the future are turning out to be deeply conservative. And modelling that was done as late as 2004, dealing with hurricane activity, was suggesting just modest increase in hurricane activity in about 2080. But what we see in the real world is that over the last 30 years or so, the amount of energy that's expended by hurricanes worldwide has increased by 60%. So that is a massive increase, and much more of that energy budget's going to the extreme weather events, the Category 4 and 5 hurricanes. And just recently in my own country of Australia, over the last few days, we've seen an exceptional Category 5 hurricane have a very big impact on northeastern Queensland.
Can you talk a little bit more about how weather patterns appear to be changing?
Yeah, well, what you see, as you start warming the atmosphere, you just create a more energetic atmosphere. And that happens because as the air warms, it can hold more water vapour, and water vapour is hurricane fuel, it's latent heat energy, and it drives many of the phenomena that we recognise as weather. So, yeah, we get more extreme weather events such as hurricanes. We also get longer and more severe and hotter droughts. And the European summer of 2003 was a great example of that. You know, that was such a warm summer. Statistically, you might expect it to occur once every 50,000 years. But, you know, those sort of warm summers are just becoming increasingly frequent. And, of course, that was a very deadly event. Heat waves are the greatest killer of people of all extreme weather events. So those sort of things are on the increase. We're seeing changes in rainfall patterns. We're seeing certainly declines in snowfall in some areas, and decline in, or a shift in the seasons, I should say, where you're getting shorter winters. Often they're just as cold as ever before, but they're getting a little bit shorter, and quite long autumns.
Well, where I live in Philadelphia, there wasn't a lot of snow this winter. And knock wood, there won't be much snow in the early spring either. But see, but that's, I'm saying knock wood. I mean, I like it when it doesn't snow, but on the other hand, there's a part of me that's always thinking, uh-oh, is this a symptom of global warming? Does this mean trouble? And do we risk going too far if every time the winter where we live is a little more mild, we attribute it to global warming?
Yeah, look, there's a hell of a lot of noise in the world's climate system, so the weather's very variable year to year. And it's very hard to know whether any single event is the result of climate change or global warming. In fact, it's probably the wrong question to ask, really. The weather system is so intricate and so, chaotic in some ways. You know the old saying about the butterfly's wing in the Amazon, fluttering of a butterfly's wing starts a hurricane in the Caribbean. Mm-hmm. Well, there's some sort of truth to that saying. And what scientists are trying to tell you by giving you examples like that is that the old ways we think about cause and effect are probably not the most productive ways to think about the way the weather system works, because they are full of so many positive feedback loops that takes small initial changes and then amplifies them, that cause and effect, as we often think about it, becomes less meaningful.
So if there was less snow in Philadelphia this winter, I shouldn't really make anything of that.
I'd keep my eye on it, because I don't know the specifics of the area where you live, but that may be just normal variability. But what I certainly notice is that in Sydney, where I spent many years living, the decline in rainfall there has been prolonged and very sustained, and that is very clearly tied in terms of theoretical models to what we see in a changing global system. So it's the longer term view often that gives you the key to understanding whether these are meaningful events or not.
You talked about surprising cause and effect in the weather system. Can you give us an example?
Yeah, look, I think one of the most interesting examples that's come to light recently came about as a result of the collapse of an ice shelf in the Antarctic. This ice shelf was about the size of the country of Luxembourg, so over 1,000 square miles. And when it collapsed, people learned a couple of really interesting things. The first was that the collapse was extremely rapid. It occurred over a couple of weeks. And once the ice had cleared, people drilled into the sediment under that ice shelf and found that ice shelf had been stable for 12,000 years. So such a sudden collapse was really startling. And then people started looking at the glaciers that feed into that ice shelf and realised that they had sped up enormously as a result of the ice shelf collapse. So there was even more ice coming into the ocean. And the other thing that happened when people looked at this situation even more closely was that they saw that the ice had been reflecting lots and lots of sunlight directly back into space, because ice is bright. That's what it does. Reflects heat and sun's energy back into space so it doesn't warm the planet. But once that's replaced with dark water, instead of 90% of the energy of the sun getting reflected back to space, you get 90% of it being absorbed by the oceans. And the oceans in that area had increased in temperature just a tiny bit. I mean, that water was still cold enough to kill you in a couple of minutes if you're unlucky enough to fall into it. But the increasing warmth was starting to eat away at the bottom of ice shelves. And so what we see there is a total change in the system, a very powerful positive feedback loop, where we're getting more heat energy into the oceans, which is leading to the destabilisation now of other ice shelves in the Antarctic. And of course that glacial flow is bringing yet ever more ice into the oceans. And so what we learnt from that event has forced us really to revise in a very profound way what we think will happen in terms of sea level rise globally as a result of climate change.
I guess this is an example of what you mean when you say the most worrisome symptoms of warming are happening at the poles.
Yeah, that is certainly true. And, you know, the symptoms that you could see from outer space are the ones that are happening at the poles. You know, the fact that the Arctic ice cap is just shrinking so much. And that ice cap has been there for 3 million or so years, It's really, and that in a way, again, just at the cutting edge of science, we're beginning to learn is something that might be unique to this latest warming caused by greenhouse gases. I mean, greenhouse gases trap heat most effectively at temperatures more typical at the poles than at the equator, So this warming of the poles might be something relatively new, and it is, for me, a deeply disturbing event, to think that we're destabilising ecosystems that have been there for millions of years and changing the way our planet looks from space. It's quite an amazing concept.
How does it look different from space?
Well, the ice caps, which are so bright, are melting away, and by the end of this century, it's quite likely there will be no polar ice cap in summer. I mean, you could see that from the moon, you could see it from, way, way out into space. So that is a profound change to our planet. It really is. It's changing the energy balance of our planet. It will mean the destruction of an ecosystem that has so many unique forms of life in it. Polar bears, narwhals, walrus, seals, and a whole lot of species that live, of course, on the tundra around the Arctic Ocean. So they're very, very big scale changes. And the thing that gets me, Terry, is when I think, why are we doing this? Are we doing this just so that we can drive big cars and just so we can continue to waste electricity? I mean, if so, it seems like some kind of madness.
Is there a tipping point with the ice where we've gone too far and it's too late to turn back?
Look, a tipping point certainly does exist as far as the melting of the ice caps goes. No one knows where that tipping point is. But what we do know now, from looking at the shrinking Arctic ice cap and the collapse of ice shelves around Antarctica, that we must be getting somewhat close to it. It's another very good argument for taking actions sooner rather than later in terms of climate change.
You did a lot of travel for your book on global warming. Can you tell us about one of the stops along the way where you saw things that were of great concern to you?
Yes, well, certainly. When I did my tour around Australia, I stopped in coastal Queensland and talked to people there. And, there people are now building an enormous port so that Australia can export yet more coal to the rest of the world, which will exacerbate this problem. 40% of the world's CO2 emissions come from burning coal, and Australia is the biggest coal exporter. And there, just offshore from where that port was being built, we have the Great Barrier Reef, where the corals are dying because the water's just getting too warm for them. We've had catastrophic kills of coral now virtually every year since 1998, and this year was another year, saw another period of massive coral death. And on the mountains just behind where I was speaking, some of Australia's most ancient rainforest diversity was under threat from that same warming, where every year, we get more extreme weather events, so dry seasons. We have the warmer, lower tropical jungle creeping up from below, squeezing those precious, ancient, cool forest relics higher and higher up the mountains. And again, this year off that same coast, that the same warm water that killed the corals brought this massive Category 5 cyclone right into the middle of northeastern Queensland. So that area, to me, encompassed it all. In one small area, you could see the processes going on, from cause through to very dismal effect.
Your book was written before Hurricane Katrina, but you have an afterword that you wrote after the hurricane in which you address it a little bit. It seems to me a lot of scientists who believe that the planet is warming, a lot of those same scientists are still reluctant to say for certain whether Hurricane Katrina was the after effect. It was an after effect of global warming. How much evidence do you think that there is, whether there's any connection or not?
Well, look, there is a connection, but the trouble with looking at any single weather event is that, these are highly complex systems with a fair degree of randomness built into them. So whether Hurricane Katrina passed 200 miles from New Orleans and was a Category 3 or a Category 5, or whether it was a direct hit on the city, all has a pretty big element of random chance and luck in it, So so the damage that was caused by the hurricane, no one can say is a result of climate change. But what we can say is that the total energy budget for hurricanes like Katrina have increased dramatically over the last 30 years. They've increased by 60%. So the chances of having these big hurricanes has increased a lot, and also more of that energy budget is going to the most destructive of all hurricanes, the big Category 4s and 5s, and we are seeing an increase in those very destructive weather events over the last 30 years, and that will just continue. The more we warm the atmosphere, the more water vapours can be absorbed by the atmosphere, and water vapour is hurricane fuel. So that's where the link is. It's not any single event. No one can say that Katrina hitting New Orleans was Gaia taking revenge for damaging the world's climate system. But what we can say is that sort of event is ever more likely the more we pollute our atmosphere with these greenhouse gases.
You write a little bit in the book about how airplanes may be affecting the climate. As an example, you point to September 11th, and you say in the couple of days that planes were grounded in the United States after September 11th, temperatures rose by a couple of degrees. That would seem to me like something that was probably completely unconnected. But what is the connection scientists think might exist?
Well, the connection really comes through this new theory of global dimming. And what people think is that a number of things are happening in the atmosphere that are masking the effects of climate change. And one of the most important of those is these aircraft contrails. So whenever you see aircraft go overhead, they leave a vapour trail, and that vapour trail can turn into cirrus clouds, and that cirrus cloud reflects the sunlight back into space. It stops it from hitting the surface of the planet. So therefore, it's acting as a cooling agent. And September the 11th, for all its horrific tragedy, offered this independent experiment to climatologists that was absolutely a unique opportunity to see what the world was like, and particularly the Northern Hemisphere, without aircraft, without air travel. And the results really were astonishing. They're actually quite convincing that this the impact of contrails on the world's climate is actually quite profound. As you said, a couple of degrees over North America.
So you think that planes are actually masking, or might be masking, the effects of global warming?
That's right. I mean, one of the things that mystifies climate scientists is why, with the massive amount of carbon dioxide that we've put into the atmosphere now, we're not seeing more warming. And part of the reason for that seems to be that jet aircraft and their contrails are masking that effect, but also that particulate pollution and sulphur dioxide pollution from burning coal is contributing to that masking effect as well. So one of the great concerns we've got is that as people develop cleaner fuels, particularly in China, places like that, we shall see more of a runaway warming. So, as we learn about this climate system, we realise we've got a significant job ahead of us to coordinate our activities internationally to make sure we can avoid the worst impacts of climate change.
I'm sorry, what you said just sounds so counterintuitive. If China develops cleaner fuel, we will more quickly see the effects of global warming?
That's right, because China burns horrifically dirty coal at the moment. If you look at China from space, you see that its cities are black. They're just about the only cities that are black when you look at them from space. And that's a lot of that sulphur dioxide and particulate pollution from burning this very foul, dirty coal. Once China starts cleaning up its coal, and it will do that for health reasons. I mean, many, many Chinese die every year from lung diseases as a result of that pollution. We shall start to see more warming because that sulphur dioxide, those terrible brown smogs that typify China, will start to clear up, and we'll see more of the sunlight reaching the Earth's surface and turning into heat energy.
If you're just joining us, my guest is Tim Flannery. He's the author of the new book, The Weather Makers: How Man is Changing the Climate and What It Means for Life on Earth. What would you like to see the United States do in terms of preventing further global warming?
You know what I'd love to see? I would love to see the United States return to the enormous energy and optimism and dynamism that characterised the country in the 1950s, 60s and 70s, and to see American industry and enterprise take up this challenge and start to invent a new future for itself, to get deeply involved in this new energy future, to use its natural assets, which are that optimism and dynamism and this great capitalist society that's developed here, to start addressing the problem, not being stuck as part of the problem, but start seeing itself as part of the solution. Because, as I said, change is inevitable. The US could be an enormous force for good in the world in terms of developing these new low emissions technologies that are required and start getting them into marketplace. No one knows how to do it better than the US.
Has the Australian government been resistant to scientific findings about global warming?
Extraordinarily so. And if you think you've got it bad in the US, then I advise you to come and visit Australia. In my country, we're the world's largest coal exporter. We've got the world's heaviest dependency on coal for generating electricity. We're per capita the world's worst polluter. And there's a lot of people making a lot of money from those industries. So, when my book came out, I was just relentlessly attacked, and as has everyone else who's spoken out. And often nasty personal attacks, not just, attacks on the science or whatever else. And so that's been dismaying for me because, again, my country's suffering, so evidently suffering the impacts of climate change. I mean, with the destruction of the Barrier Reef, having every capital city virtually in Australia now with some sort of water crisis relating back to these big shifts in rainfall that we're seeing around the planet. That was what drove me to write the book. It's, I suppose, a sense of patriotism in a way, but also a global concern. But, we need to get beyond this issue, this stupidity of arguing whether climate change exists or not, and start moving on the solutions.
As we said earlier, you were initially skeptical about global warming, and you are no longer a skeptic. You believe it's happening, and you believe it's a very urgent issue. Have you made any personal changes in your life now that you believe that global warming is happening, and that we need to do everything we can to reverse the trend?
Yeah, look, I certainly did, Terry. I must admit that while I was writing the book for about 12 months, I'd wake up feeling pretty depressed each morning to go on and continue researching it. And it's only when I came to trying to understand what the solutions are that I started to feel much, much more optimistic. And I thought, the first thing is for me to put my own house in order, which I literally did by covering the roof in solar panels and making sure that I was generating my electricity from the sun. And that's been a wonderful experiment. I've enjoyed it hugely. I'm fitter than I was before because I use hand tools now to do my tinkering rather than power tools. And we've bought a whole series of energy appliances that are just much more efficient. And yeah, there's been a cost involved with that, but I'll never have a power bill again. The solar panels I bought have a 25-year guarantee, and I'll still be producing energy after 40 years, most likely. So that was pretty easy, and I figured if I can do it, anyone can do it.
Well, Tim Flannery, thank you so much for talking with us.
Well, thank you. Thank you.